Okay, so let's talk about the range of validity for the standard series. Okay, so you can see on my whiteboard, I've cut and paste the Maclaurin expansion that you can get from your MF26. Okay, and you notice on the right hand column, okay, there is some notes in the brackets. Okay, so these are actually the range of validity for the standard series. Okay, so for example, let's talk about the easy ones first. For e to the power x, okay, this row, sine x and cosine x, okay, these two rows as well, they can take in any values of x. All right, so it's all real values of x in this case. So usually it's not much of a problem if you are dealing with these three expansions. Okay, but for the other two, okay, which is this guy and this guy, all right, there is actually some restrictions. Okay, so if you were to expand 1 plus x to the power of n, all right, the validity for the value of x must be in the modulus of x must be less than 1, which means x must be in between -1 to 1. All right, now for the ln, okay, in that case the validity would be between -1 non-inclusive all the way to 1 inclusive. Okay, and both of these are real numbers too. Okay, the x are real, but it has to be restricted to this range. Okay, now why is this important? I want you to pay attention to these. Okay, due to the fact that sometimes there might be a 1 or 2 mark question, okay, in your exams that might actually ask you for the range of validity for your expansion. And how does it work? Okay, so for example, suppose you were asked to expand 1 minus, okay, let's take a look at some okay, let's say not minus, let's just deal with 1 plus 3x to the power of n. Okay, suppose you expanded this, all right, using the methods I've shown you in the previous lessons. Now they say hence state, okay, or find the range of validity for this expansion. All right, the range of validity for x. In that case, just come back to MF26 if you don't really remember, okay, and look for this guy. All right, now we know that we have replaced x with 3x, so in the same case for the range of validity we will replace x with 3x instead. Okay, so that would be where you start. All right, and then after that, make sure that you simplify this a little bit, of course. Okay, so in that case we could expand this. Okay, we get 3x in between 1 or -1. All right, now what we want is just x, right? So we're going to divide 3 throughout the entire inequality, and that will give us -1/3 and 1/3. Okay, I hope that makes sense. All right, so that's how you figure out, and this will be your answer, okay, for that particular question. That will be the range of validity for x for this expansion. Okay, and then you get 1 mark for this. All right, it's not too bad. Okay, it's not very difficult here. Now let's take a look at a couple more examples. Okay, I'm going to erase this. Okay, now the next one, let's take a look at another binomial expansion, but in this case we have this. Okay, so 1 plus 3 over x to the power of n. Okay, so again, let's say you have expanded this and you've got the expansion in descending powers of x, okay, and then they ask for the range of validity. So what we have done is that we have replaced x with 3 over x. So in this case, again, the range of validity will be 3 over x 1. Okay, so it will require you to understand how to simplify this, and you must take the lessons on inequalities, okay, that particular topic, to learn how to do this. But over here, let's just go ahead and solve this. Okay, so again we have 3 over x is less than 1. Now what I want you to know is that when we have a modulus of x, okay, modulus of x less than a, all right, we have a that is actually going to be, oops, sorry, we have x, all right, is going to be in between a to -a. Okay, now what happens is that when we have the modulus of x, okay, greater than a, all right, then it would give us a case whereby we have x less than -a or x greater than a. All right, We actually learned this in the chapter on inequalities, okay? But over here, we are going to use this, okay? So this x could be fx or some terms, some function in x, okay? It doesn't matter. Now, the thing is, we have this, all right? What happens is that we notice that x is in the denominator, so we need to take reciprocal, okay? When we take reciprocal, this is what happens. We'll have x over 3, okay? That would actually be now greater than 1, all right? Why is that so? It's actually quite simple. It's due to the fact that, let's say we know that, okay, take note that both sides are positive numbers. So if we have 1 which is less than 2, okay, if we take reciprocal, what happens? We will have 1, okay, now larger than half, all right? Okay, I think a better example would be 3 less than 4. And then when we take reciprocal on both sides, we'll notice that 1/3 is actually larger than 1/4. Okay, so this has a condition, both sides must be positive. Okay, both sides must be positive. Of course, there are more than this, okay, on reciprocal and inequalities, but that's not the purpose of this lesson. Okay, so we won't dwell too much on that. Now, as I've mentioned, okay, so when we take reciprocal, okay, when both sides are actually positive, then what happens is we need to switch the direction of the inequality sign. And that now tallies with this guy, right? So instead of an x, we have an x over 3, okay, greater than a. So that means we would have x over 3 and x over 3 here. Okay, so let's go ahead and finish this. So that means we will have x over 3 must be less than, okay, a happens to be -1, or x over 3 must be greater than 1, okay? And then after that, we solved for x. We multiply 3 on both sides. That gives us x less than -3 or x greater than 3. Okay, so that would be our answer for the range of validity for this particular expansion. Okay, so this is a little bit tricky here, but not too difficult if you remember the basics. Okay, now we'll just look at one more example before we call it a day, and that would be, say, ln. Okay, we have ln 1. Let's take a look here. 1 plus, okay, let's change the 1 minus x over 2 in this case. Okay, so again, when we do our expansion, our series expansion, we will have replaced x with minus x plus 2, okay? We would have replaced x with minus x plus 2. And you realize over here that the x must be in between -1 to -1, okay? So in that case, we can write this down as minus x over 2, okay, less than, greater than -1, and less than or equal to 1. Okay, now let's deal with the 2 first, which is easier. So we'll multiply 2 on both sides. We get -2, okay? And then we have the minus x, and then we have 2 over here, all right? Now we need to deal with the minus, okay, next to the x. So we'll multiply -1 throughout the inequality. So that gives us x. But since we are multiplying a negative throughout the entire inequality, we need to change the direction of the sign. So this becomes this way, okay? And then we have -2, that becomes 2. And then we have 2, that becomes -2, because we multiply the entire equation by -1. Okay, let me change that. -1. All right, now usually we don't write it this way, okay? It's just more for my illustration. What we'll do is that we will just write it this way, okay? Make sure that the arrows are always pointing to the left. So this would be it. So usually what we'll do is we'll skip this entirely. We'll skip this entirely and just write the last line over here, okay? We'll just write the last line over here. So that will be our answer. Okay, I hope that makes sense. So there you go. That's how you find the range of validity for the standard series, and in particular, it usually would be the binomial expansion or the ln expansion. Okay.